Hello, I'm Robert Tozer from Operation Intelligence. I'm going to talk a little bit about data center air management. It's going to be a brief introduction. Two problems with data centers are bypass and recirculation. So bypass is cold air which is coming out of the floor, or cold air supplied from the cooling units, which is bypassing IT equipment and doesn't make it to the rack, which is where it should be providing the cooling to, and hence the rack warms up. Recirculation is air which is coming off the back of a server, like this one here, and is entering the air intake here, which is mixing up with the cold air provided by the cooling units, and hence you're getting a warmer temperature at the server or IT equipment inlet. This is a typical arrangement of a data center. We've got a hot aisle, cold aisle arrangement. This is the cold aisle, this is the hot aisle, that's the cold aisle here. And that's a cross section showing you the cryo unit, air inlet going, air inlet to the cryo unit, cold air coming out of the cryo unit, coming out of the floor. We've got floor grills going into the servers here and here. The hot air comes out the back here. Cold air goes in here, exactly like in this rack over here, and you get cold air coming out here, and you can see that this air is only hot air coming from the exhaust of the servers, and this is only cold air going into the servers here and here. So the reality is bypass still occurs, because you get, although the cold air is going in there, you get a lot of cold air coming out of these cable cutouts, which is where cables come through from the raised floor to the rack, but the hole is too big and you get loads of cold air coming out the back here. You can easily notice this if you just stand in this cold air and put your hand on the door at the back. You'll feel that temperature is cold. That's one source. Another source is, for example, in this hot aisle, if you've got a grill, which shouldn't be there, and this air is just mixing with the hot air coming out the back of the grills, and so the back of the servers, and just going back to your cryo unit over here. And the other source of bypass is when you get a grill which is supplying too much air in a cold aisle like this one. They're supplying this server here, but there's excess air, and of course this is bypass air. So recirculation, vertical recirculation, as you got in this case, you get this hot air coming at the back of the server here, going into the server here, so it's a higher temperature there. This is internal to the rack. You can also have the same thing going on external to the rack. This is quite easy to notice. Just put your hand inside the rack where the blanking panel should be, and you'll notice the hot air coming back. And you can put it on top of the rack, and you notice many times hot air coming back here. You get the same thing horizontally. So if you look at the inside the rack, on the side of the server, you'll see hot air coming back, particularly if there are no brushes or no Correx to blanket off. And particularly on the last rack of a row of racks like this one, you can notice it out externally to the rack. And you just put your hand here and you see the hot air coming back this way. So you can, just by using your hand, you can get a sense of if you do actually have bypass and recirculation. It's a pretty good parameter actually. So if you were to do a survey inside the data hall of all the servers, in this case there's, I can't remember, 20 odd servers here. That's one, that's another, that's another, that's another. And all we've done here is just put them into ascending order of inlet temperatures to the servers. So we got a rack here at 14, 15, 16, that's 20. And you can see here you've got even air temperatures going in at over 33 degrees there. Now, what we've done here is you do all the best practices for air management, which that's okay. That'll be another video what to do exactly there. But once you do that, you'll end up with a line like this one, line number 2, which is this dark green line, where you can see the temperatures are much more uniform. And at this point, you've finished doing your air management, and this is when you start to achieve energy savings by doing two things. You reduce the fan speed in your cryo units, and you also increase the set points on your cooling systems. Both of those will reduce energy consumption. So you end up with this line 3 here, whereby these servers here, which were overheating, above For example, the recommended temperature of 27 degrees recommended by ASHRAE, all these servers were out of range there, and now they're actually within the correct boundary, or within the recommended boundary. But at the same time, you've got less risk. You saved energy. You have less energy wasted because you've actually managed to raise set points and adjust the fan speeds down. If you this is a model representing now one cryo unit and one IT equipment, but it represents a whole data center. And there are typically 4 characteristic temperatures in a data center: air going into the CRA, air coming out of the CRA, air going into IT equipment, air coming out of IT equipment. And every data hall will have these 4 characteristic temperatures. They're approximately the average, or the weighted average, approximately. But they represent what's going on. The width of these lines represents the airflow rate. The color with the scale represents the temperature. So we've got cold air coming out of the CRA unit of 17, of which 50% of it is bypassed. The other 50% is what goes to the IT equipment. Of all the air going into IT equipment, roughly we've got 40% which is being recirculated here. It just goes round here, round this way, and mixes with this air here, and hence you get 21 degrees here. The hot air coming out the back of the server, 27 degrees, then goes back to the CRA units, but it's mixed with this cold air at 17 degrees, hence the temperature going into your CRA unit is now 22 degrees. So this is the last slide, just explaining why air management is an energy enabler. So we use the same temperatures as we had before, representing the data center with one CRA unit and one IT equipment. Same temperatures, 17, 27 here, 21 and 27 degrees here. Now, if we look at the bypass, which is this air here, you can see that this bypass is what is reducing this temperature of 27 degrees I have coming off the back of the server and lowering it to 22 degrees here. So 27 degrees with air at 17 here, bringing it down to 22 degrees. I've actually got 5 degrees depression of temperature on my return path because of bypass. If I didn't have any bypass, that temperature going back to my CRA unit would be 27 degrees. So this difference of 5 degrees is telling me that I've actually got quite a lot of bypass here. And this is quite common in data centers. 1 degree of depression there, probably good. 10 degrees, very bad. 5 degrees, well, there's what you can do with it. But the important thing here is that when you look at bypass here, this CRA unit is using its fan to supply cold air here, of which only 50%, as we saw in the previous case, was going into IT equipment. The other 50% was bypassing this way. This means that this fan is working twice as much as it needs to be, and you have an opportunity to save energy there. The other thing to notice is recirculation. If I didn't have any recirculation at all, this air at 21 degrees would be actually 17 degrees, because it is 21 because this air at 17 is mixing with this air at 27 to give me 21 degrees. So I've actually got 4 degrees worth of recirculation. And if I didn't have recirculation, then what I could do is I could supply this, rather supply at 17 degrees, I could supply at say 21 degrees, and I could save energy on my compressors because I could actually have a much higher COP, or coefficient of performance, on my cooling system, and I could even have more hours of free cooling if I have a free cooling system. So recirculation is an enabler for saving energy on the cooling or refrigeration side. Bypass, or reducing bypass, is an enabler for your fan systems. Okay, thank you very much.